All right, today's lesson is slope from graphs and tables. So, slope measures the steepness of a line. And so, we sometimes think of this as the slant. So, slope measures the steepness of a line. It is the rate of vertical change to horizontal change. And you'll see what I'm talking about there in a minute. So it's the rate of vertical change to horizontal change. Okay, let's draw our slope dude. So this line here has what kind of slope? Negative. How about this line? What's he got? Positive. How about our vertical line? What kind of slope? Undefined. And how about our horizontal line? What kind of slope? 0. There's our slope dude. So hopefully everybody is working on their slope dude project, trying to think of something creative to do. Let's just look at our algebra ski slopes in practice. What kind of slope does this line right here have? Positive. How about this line? Negative. How about the horizontal line? 0. And how about our vertical line? Undefined. Okay, down below we have several ways to think of slope. And as we go through different problems, we'll use one versus another one. So the first one is what we wrote up above. Slope is our vertical change. Sorry, can't fit that very good. Over our horizontal change. Our vertical change over our horizontal change. Another way we think of this a lot of times is rise over run. If I ever give you a picture of a graph, that's what I'm going to say a lot. Count your rise over your run or your fall over your run. Okay, rise is what we do up or down. So that's why I say rise or fall over our run. And our run could be left or it could be right. It just depends. So we'll talk about that here in a minute. Okay, and another thing looks like this. And this stands for the change in your y over the change in your x. So these triangles are called delta symbols, and it means change in your y over change in your x. In a little bit, we're going to look at tables, and this is the formula we use when we look at tables, the change in the y over the change in the x. Okay, some examples. This says find the slope between each set of points. So first I want to find the slope between A and B. So what do you notice? That's a vertical line. So we already know that slope. What is the slope if it's vertical? That's right, it's undefined. Then it wants us to find the slope between B and C. So B to C. Now one thing I really want you guys to do is to count from left to right, just like how we read from left to right. So if you ever are looking at a picture and you're asked to find the slope, let's count from left to right instead of right to left. That way we're all doing the same thing. So to get from B to C, I want to count my rise over run or my fall over run. And to get from B to C, I fall. So how many do I fall to get from here to here? So I'm level with that. 1, 2, 3. If I fall 3, then that would be a negative 3 over. After I fall 3, what do? I go right, 1, 2, 3. And if you go right, that's a positive 3. And then we always reduce fractions. So slope is a fraction most of the time, and negative 3 divided by 3 makes negative 1. So a couple things I just want to say before we move on. If you ever count up, or if you ever count to the right, that is a positive count. If you ever count down, or if you ever happen to count to the left, that is a negative count. But I want you to get into a practice of counting from the left point to the right point. So like B to C, I'm just going to do that again. I fell 1, 2, 3, so that's a negative 3, and I go right 1, 2, 3, so that's a positive 3. Okay, now let's find the slope between C and D. So to get from C to D, I'm going to count from left to right. To get from C to D, this time I rise. So I rise 1, 2, 3, 4, 5, 6. And since I went up 6, it's a positive 6. And after I go up 6, I go right 1, 2, 3, 4. And since I went right, it's a positive 4. Always, always, always reduce. If I divide both of those numbers by 2, I get 3 halves, 3 over 2. So one thing about counting, and I'm just going to say this because I've seen a few students do it over the past, once you start counting, I will see some students go 1, but they haven't moved. So you don't get to count 1 until you've actually moved a space. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Okay, and then the last one is, what is the slope between D and A? Well, what kind of line do we have between D and A? Horizontal line, so what's the slope? 0. Okay, let's look at this next example down here. It says, find the slope of the line in the cell phone cost example, and then it's going to ask the meaning of the slope. Okay, so I'm just going to count from this point to this point, but I could count from here to here, from here to here, from here to here. You just need to pick any 2 points on the line and you'll count your rise over your run or your fall over run, depending on what's happening. So to get from here to here, how much do I rise? Pay attention to the scale. I rise 25, so it's a positive 25. And then I run how much? I run from here to here. Pay attention to the scale, and that is a space of 100. Okay, and then I can reduce this. I can divide both of these by 25, which makes 1/4. And that's the slope on my line. Now 6 says, what's the meaning of the slope? So I found my slope to be 1 over 4. Now let's talk about what that means. The 1 is what I went up. And so what is the axis talking about when you go up? Well, our y-axis is talking about total cost. So the 1 is referring to total cost. The 4 is what we ran, and our running happens on the x-axis, and the x-axis is talking about minutes on the cell phone. So the 4 is talking about minutes on cell phone. So let's try to put this in a sentence. 1's the cost, 4 is the minutes on cell phone. So what might you say there? It costs $1 for every 4 minutes on the cell phone. So it costs $1, and I can say per 4 minutes on the cell phone. So it costs $1 per 4 minutes on the cell phone, or you could say it costs $1 for every 4 minutes on the cell phone. Something like that. Okay, are you having fun yet? All right, let's flip to the back. Flip. Now, if you'll notice on this page, we see a bunch of tables. So when I'm asked to find the slope from tables, this is how I do it. I find the change in my y, and I divide by the change in my x. So I'm going to write that down so you don't forget. I take the change in my y, and I divide by the change in my x. So let's see what I mean by change in y and change in x. I'm going to start with my x's, and this is what I mean by the change. How do you get from a -1 to a 0? You go up 1. How do you get from 0 to 1? You go up 1. How do you get from 1 to 2? You go up 1. Those are the changes in my x's. Now let's find the change in our y's. How do you get from 3 to 2? You go down 1. How do you get from 2 to 1? You go down 1. How do you get from 1 to 0? You go down 1. So I'm going to take the change in my y, and I'm going to divide by the change in my x. So the change in my y was -1, and I divide by the change in my x, which is +1. And that's what I got the whole way through, -1 over +1, -1 over +1. So this is my slope, -1 over 1, which I could just write as -1. Okay, let's try it for some more tables. So first I'm going to find the change in my x's. So how do you get from -4 to -4? Don't do anything. How do you get from -4 to 4? -4 to -4? You don't do anything. How do you get from -4 to -4? Don't do anything. Okay, let's look at the change in the y's. How do you get from 3 to 1? You go down 2. How do you get from 1 to 0? You go down 1. How do you get from 0 to 5? You go down 5. So let me calculate the change in my y over the change in my x. Well, first, the change in my y was -2. So I would take -2 divided by the change in my x, which is 0. And then the next one, the change in my y is -1, and I would divide by the change in my x, which is 0. And the last one, the change in my y was -5, and if I divide by the change in my x, that's 0. Well, notice we have 0 in the denominator every time. So what does that mean? Do you know? Let me just look at this problem here. I'm trying to take -2 and divide it by 0. What can I multiply 0 with to get a -2? Nothing. No matter what you multiply with 0, you'll always get a 0. You'll never get anything else. So this is said to be undefined. Now, a little memory device I learned years ago is, see how the 0 is under the fraction bar? When the 0 is under the fraction bar, the slope is undefined. Kind of see how you see the word under and undefined? When the 0 is under the fraction bar, undefined. Under, undefined. Under, undefined. Now, just to test your memories, if the slope of this line is undefined, what would the line look like if you plotted all these points? That's right, it would be a vertical line. Good job. Okay, let's look at 8. I'm going to do the same thing. I'm going to find the change in my x, change in my y's, and then go from there. So how do you get from -3 to -1? Up 2. How do you get from -1 to 0? Up 1. How do you get from 0 to 1? Up 1. Now y's. How do you get from -14 to -10? Up 4. How do you get from -10 to -8? Up 2. And how do you get from -8 to -6? Up 2. So I'm going to take the change in my y and divide by the change in my x. I'm going to actually show my work down here. So I take the change in my y, which is 4, and I divide by the change in my x, which is 2. Let's reduce that. What's 4 divided by 2? 2. Now, let's just check to see if that's what the change is for the whole rest of the table. So if I look at the next one, I take the change in my y, which is 2, and I divide by the change in my x, which is 1. And is 2 over 1 the same thing as the 2? Yep. And this one, I get 2 over 1. So that is my slope, 2 over 1, which you could just say 2. All right, number 10. The changes in the x's. How do you get from 8 to 6? Down 2. From 6 to 4. Down 2. From 4 to 0. Down 4. How do you get from 2 to 2? Don't move at all. 2 to 2, don't move at all. 2 to 2, don't move at all. Okay, so I'm going to take the change in my y, and I'm going to divide by the change in my x. So the change in my y is 0, and I divide by the change in my x, which is -2. Then I've got another 0 over negative 2, and then I've got a 0 over negative 4. So both of these have a 0 in the numerator. So let's try this problem. 0 divided by negative 2. What could you multiply negative 2 with to get a 0? 0. Negative 2 times 0 is 0. So this has a value of 0, and this is going to have a value of 0. If 0 is in the numerator, the slope is always 0. So my slope is 0. Now, what does this line look like? If the slope is 0, it is a horizontal line. Very nice. Okay, and last one. Number 11, we're asked to find the slope, and then we're asked to talk about what it means. So I still have a table. I'm going to do it the same way I did the last 4. How do you get from 0 to 8? Up 8. How do you get from 8 to 12? Up 4. How do you get from 12 to 15? Up 3. How do you get from 100 to 60? Down 40. How do you get from 60 to 40? Down 20. And how do you get from 40 to 25? Down 15. Okay, so let's start calculating the change in our y divided by the change in our x. I've got different things going on here, so let's just check. My first change in my y was negative 40, and I divide by the change in my x, which is 8. What does that reduce to be? That's right, it reduces to be negative 5. Let's see if it reduces to be negative 5 the whole way through the table. My second change in my y was negative 20, and I divide by the change in my x, which is 4. What does negative 20 over 4 reduce to be? That's right, negative 5. And then my last one, I had a change of negative 15 in my y, and I had a change of 3 in my x. And what's negative 15 divided by 3? That's right, negative 5. So all the way through the chart, I found that my slope is negative 5. Now I want to know, what does this mean? So remember, that is negative 5 over 1. Negative 5 was the change in my y, and y is talking about the amount on gift card. I'm just going to say amount on card. The 1 was the change in my x, and my x is talking about the movies I attend. So I'm just going to write movies attended. So the amount on the card is negative 5 over the movies I attended 1. What do you think this means? We're talking about movies attended using a gift card and the amount on the gift card. What do you think that means? It means $5 is used each time the gift card is used. So $5 is used each time the gift card is used. And that's all for me today, folks. Smiley face.